Hello, everyone, and welcome to this demonstration of OpenShift Virtualization. My name is Patrick Freeman, and today we're going to explore how OpenShift Virtualization brings traditional virtual machines into the cloud-native world, allowing you to manage VMs and containers from a single platform. So in this overview, I'll cover what's OpenShift Virtualization and why it's important. And then we'll jump into a quick tour of the OpenShift console for VM management. And then we'll jump into demonstrating the creation of a new virtual machine. And then from there, we'll briefly showcase some essential VM lifecycle operations and then touch on advanced features and integration. So what exactly is OpenShift Virtualization? At its core, it's an add-on to OpenShift that allows you to run virtual machines alongside your containers on the same OpenShift cluster using some of the same Kubernetes toolings and workflows that you may be familiar with. Think of it as bringing your traditional VM workloads onto a modern Kubernetes native platform. This means you can leverage OpenShift's powerful features like self-service provisioning, GitOps, advanced networking, and monitoring for both your application workloads and your VM workloads. The technology behind everything is KubeVirt, which is an open source project that extends Kubernetes to enable the management of VMs. OpenShift Virtualization productionizes and enhances KubeVirt, making it enterprise ready. So first, let's log into the OpenShift console here. We're going to log in using our admin credentials. However, if you have Active Directory or SAML or single sign-on in your environment, you can leverage those authentication backends as well with OpenShift, creating a more seamless experience from a login perspective. So first I'm going to log in here. Okay, when I log into OpenShift, I'm first presented with a bird's eye view of the cluster. I can see things like essential things like the status of different components from the cluster to the plugins to the control plane, the operators. And then also key details around the cluster, like, for example, the cluster's API address. So everything that we're doing here today, for the most part, through the user interface, you can also do programmatically through the API that's available with OpenShift as well. So let's dive a little bit deeper into the console. The most important thing I want to take a look at today is virtualization, but just know from a platform perspective, you have the capability to manage your entire environment and teams from a single source of truth here. You can divide the different teams up into projects. These projects create the isolation that you need to ensure that you have integrity across your environments. For example, if you don't want your database team seeing your security team resources, you can create that separation through projects. But first thing I'm going to look at is OpenShift Virtualization. So here's an overview. When you first click on the overview, you're presented with a bird's eye view of everything from your resources to top consumers to migrations that are taking place, if any, and as well as settings in your environment. So whenever you need to get that big picture of what's going on in your environment, you know, how things are looking from an operational perspective, this will be your first stop here. So in this environment, I have 3 virtual machines, which are consuming 5 vCPU and roughly about 500 megabytes of memory. And then from a status standpoint, if there's any errors or anything that's, transpiring in this cluster, you'll be able to see it here under the status standpoint. Next, we're going to take a look at the virtual machine catalog. So you could think of this as essentially what the name implies. It's a catalog. It's a catalog where folks can create their own virtual machines in a self-service fashion. This catalog helps you create standards. So if you have a standard image, RHEL image, or virtual machine image that you want to deploy, this is where you can add it to the cluster so that folks can go in here and select only the approved images. Just something to keep in mind. We support, you can deploy CentOS, Fedora, RHEL, and even Windows virtual machines, depending on your needs as well. And then just keep walking through here real quick. So virtual machines, if I click on the virtual machines tab, you'll just get an idea of, or a list of the virtual machines that you have running in your environment. If I want to drill down into any of these virtual machines or some of the attributes of the virtual machines like namespaces, I can see that. If I want to see what's going on with a particular virtual machine, I can just simply click on it. And in this case, I see that it's running. If I want to stop this virtual machine, if I want to cycle it to restart it in case something goes wrong, I can just click on this as well. It's a really great feature to have, especially if you're coming from a VMware environment or just a virtualization environment in general. You have some of the same capabilities and features. They might look a little different, but in essence, you get some of the same capabilities overall. We have metrics, so I can see how much CPU, memory, storage, how much performance we're getting from my storage, network input and output, the bandwidth as well, and then anything else that's going on in that environment. If I want to make changes to this virtual machine or some of the configurations, I have the capability to edit it through the YAML configuration here. I can also change the baseline configuration that's available. So if I want to add more memory to this virtual machine, I can increase it here, as well as the CPU and so on and so forth. If I want to see what events are going on in real time, I have access. I can just click on the events tab. I also have a console tab. So if I want to be able to log into this machine directly without having to SSH into it externally, I can do that right here. And then we have the snapshots. If I want to take a snapshot of a point in time of that virtual machine, let's say if I'm planning an upgrade or maybe I'm testing something out, I have the capability to do that all right here at my fingertips. So let's take a look at a template. In this case, I don't have a template, but if I wanted to create one, I could just simply go here, create a template, and click create. If I wanted to view the instance types that are available, I can go here and do that as well. It all depends. This is just as customizable as you want it. You can configure, different instance types if you want to have GPU backed instance types. If you're doing machine learning or AI, supporting those use cases, you have that flexibility as well. And then from a preferences standpoint, things that I want to be standardized across the environment, such as different image types, I can control all that right here at my fingertips. Then bootable, then migration policies, if I want to do that, and even checkups. So next, let's create a virtual machine. Now to do that, first, what I would do is I would select the image type I want to use. So in this case, I want to use RHEL 10 because RHEL 10 was just announced at Red Hat Summit. So I want to take a look at that and kick the tires a little bit. I'll leave all the defaults, but just know if you want to customize anything here, like I said, GPUs, depending on your use case, If you think you're going to be, if you just need a general purpose VM, you can do that. If you need a GPU, if you're going to be working on maybe some database use cases and you need a memory intensive instance type, you can select that. So just keep in mind and select according to your use case. And if you want to increase disk capacity here, which in my case I do, you can increase that dynamically. And then after that, depending on if you want to customize anything, you can customize it, but we want to keep it simple for demonstration purposes. So in this case, we'll just click Create Virtual Machine. Now this may take a few minutes, but as OpenShift is doing its thing, you'll see it go through its phases from the creation. Right now we're at the provision phase. While this virtual machine is being created, we can look at the events that's taking place in real time here using the Events tab. Okay, now that virtual machine is starting up. It's already done its thing, and before I can finish my sentence here, it's running. So now I have a running virtual machine with just a few simple clicks. If I want to log into that virtual machine, I can do so here. Once it's fully booted, a lot of this may look familiar if you're familiar with RHEL. Similar boot up screen here. It's the server's just doing its thing as far as starting up. Give it a few more seconds. So that's it. The virtual machine is now up and running. If I want to log in, I can log into it right here. You also have, a couple of different options as far as the different consoles. You have the VNC console, the serial console. You can connect to it here. If you want to SSH to it, you just have to create a route to make it externally accessible, or you can use the CLI, which can programmatically replicate SSH, and you can SSH directly to the machine that way as well. We don't have enough time for that in today's demo. Just wanted to show you some of the basic mechanics of how OpenShift Virtualization works. So today, in summary, we looked at how OpenShift Virtualization empowers you to consolidate your VM and container workloads onto a single unified platform. We looked at how you can leverage Kubernetes native APIs and toolings for the VM lifecycle management. We discussed some of the benefits from OpenShift's robust features like self-service networking, monitoring for virtualized environments. And then we see how this can accelerate your journey to a hybrid cloud and a modern application delivery. Thank you.